I want to take a few minutes to talk about input and output and function notation. So we have a table here that represents a function. Anytime we talk about representing a function, that means the input each input has exactly one output. So we see -6 is only paired with 8. We don't see anywhere else where -6 is paired with a different value. That's what the function definition is. Each input has exactly one output. So when we talk about input and output, the x part of our table is our input, and the f of x or y, those are the same thing. F of x is the same thing as y. That side of our table is the output. So to answer this question, which value is an output of the function, you would choose any answer from the y side of the table. Oftentimes we write this in function notation. F of x is equal to, well, in the very first row, we know that f of x is equal to 8 when, for what x value is the answer 8, f of -6 is equal to 8, which just means when x is -6, y is 8. So again, the x side is the input, also called your domain, also called your independent variable. The y side is the output. We'll also use words like range to represent the y values, and dependent variable. Let's look at another example. Consider the function represented by this equation. Which answer shows the equation written in function notation with x as the independent variable? We always use the x as the independent variable unless we're using something else to represent x and y, like distance versus time, distance over time. Distance depends on how much time you've been traveling, so time would be the independent variable, distance would be the dependent variable. So we can use different variables, but the x, what we use for x, is still the independent variable. So here we want to write something in function notation. Function notation is when you get f of x equals, and again, what did we say f of x is the same as? F of x is the same thing as y equals. So I need to take this equation and get it in y equals form. So if I want y equals, that means I want to get y by itself. Since y is already positive on the left-hand side of the equal sign, I'm going to use inverse operations. Minus 6x, the inverse of that is plus 6x. So plus 6x on both sides. And minus 9, the inverse of that is plus 9. Plus 9 on both sides. They're not like terms, so I just leave it as 6x plus 9. So my equation in function notation is y equals 6x plus 9, or f of x equals 6x plus 9. One more example just to reiterate input versus output. What is true regarding the graph function? Well, again, when you have f of x equals, so here if we had f of x equals y, we know that f of x is equal to y. Basically, that tells me that the number inside the parentheses is my x value, and the number that is equal to is my y value. So I can write these as ordered pairs. Inside the parentheses, 0, and then equals 3 is my y. Inside the parentheses is 5, equals -1. 3, comma 2, and 2, comma -2. So when I look at my line contains which point? Is 0, 3 on that line? No. Is 5, -1 on that line? Yes. Is 3, 2 on the line? No. Is 2, -2 on the line? No. So the correct answer would be 5, -1. Thank you.